Good afternoon, everyone. Thank you for joining this presentation on the European Seismic Risk Model 2020. I'll be telling you about this new open community developed risk model for Europe. I'm presenting this work on behalf of a number of my colleagues, some of whom are mentioned on this slide, but many are linked at this web link here. People from all over Europe, engineers, seismologists, geotechnical engineers that have helped develop both the hazard model, which you've heard about already today, as well as the seismic risk components of the model. There are four main components required to develop a European seismic risk model. You've heard a lot about the seismic hazard model, both in the presentations in the previous part of this special session, but also Domenico Giardini's presentation. So I'm not going to go into too much detail on the hazard model, and instead I'm going to tell you about the other components that we need to develop a European seismic risk model, in particular a site amplification model. So the hazard is on a reference rock, and instead we need to calculate the ground motions underneath the building. So we need to estimate what is the amplification caused by the local site conditions, but this is at a whole European scale. So obviously we need a simplified method that uses proxy data. We have an exposure model which tells us about the distribution of buildings in Europe in terms of the number of those buildings, their value and occupants. We divide the buildings into three main classes: residential, commercial, and industrial, but also in terms of their structural classes, so describing them in terms of the main attributes that influence their seismic performance. Then we have a set of European vulnerability models. Vulnerability models tell us about the probability of loss given ground shaking. And in our risk model, loss is described both in terms of loss of life, but also economic loss due to structural damage. So I invite you please to attend the poster session later this afternoon, where Graham Weatherall will be telling you more in his poster about the European site amplification model. But just a few words here to tell you that we have collected data to allow us to describe the geological era in a harmonized manner across Europe, and also the topography. By the way, you will see on each of my slides a link in the top right, and this is a link to GitLab repository or a web service where this data is made available. We are making all of the data, the underlying data sets, tools, and the models available for transparency and reproducibility of the risk model. And you'll hear more about that actually later in Fabrice's talk. So these data sets have been collected, and they are directly inputs to calculate site amplification in the ground motion model. And this is just examples of what the site amplification values look like at 0.2 seconds and 1 second across Europe. And we have also developed tools to allow people to easily create the site amplification model input files for the OpenQuake engine using those input data sets, and they're available again at this repository. And this is as a function of the user's exposure model. So a user may have an exposure model where the buildings over a given region are described by a single location, and different choices can be made on how you describe the site properties. Do you take the site properties closest to the coordinate of those buildings, or do you take an average across the whole region that's being represented by that single location? The exposure model covers 44 different countries. The ones that you see in black there are the countries where we have, over the past few years, put quite a lot of effort into developing new exposure models, building upon past research, in particular that in the NERA project. And we have produced exposure models for residential, commercial, industrial buildings. We use mainly public national census data. We take it at the highest resolution that's publicly available. We collect information on dwellings, buildings, population, and workforce. The countries that you see in blue have been instead taken from past efforts, past projects. One in particular is the GED4GEM project that the Global Earthquake Model funded to produce a global model of exposure. And these countries tend to have lower levels of hazard, and that's why we have not yet been able to focus our efforts into improving more recent exposure models. But it's worth noting that the census data that we've collected over the past few years mainly comes from the 2011 census in most countries. And so there will need to be an effort going forward from this year onwards, now that updated census data will be available, to improve and update these exposure models. One of the very successful activities that's been undertaken as part of the development of the risk model is to work together with a number of structural earthquake engineers across Europe to understand how seismic design has evolved both temporally through time, but also spatially in different countries in Europe. So what you're seeing now on the right is a map of around the past 100 years, showing the different places, countries in Europe that were designed and what was the level of seismic design that was required. We classify seismic design in terms of different types of design code, low code, moderate codes, and high codes. And we also can calculate at the time of the design, what was the lateral force as a function, as a percentage of the weight of the building that the engineer needed to apply in the design. And that's what you're seeing in the figure here on the right. So in our European exposure model, we have an estimated 145 million buildings. As I mentioned before, most of the census data is from 2011, so this is probably an underestimation of the number of buildings in Europe today. They have around 45 to 50 trillion euros of value, these buildings, and we have assessed that around 20% of that value is in the industrial building stock, another 20% in the commercial, and around 60% is in residential buildings. We can also, from our model, look at how the buildings are distributed in terms of their main material, with the majority of the buildings, around 60%, constructed in unreinforced masonry. And also from our seismic design study, we know that around 15% of the buildings have been seismically designed to some level of seismic design, though the majority of those are to the very preliminary first generation of seismic design codes. These figures here, these maps here show you what the exposure model on the left, the residential, on the right, commercial, looks like in terms of its resolution when it's collected and built from this raw census data. So you can see it's very variable, the resolution. Some countries offer very high resolution census data, France, for example, and Italy. Most countries have higher resolution data for residential buildings than for commercial buildings. So for us, it was important to understand the impact of this varying resolution on our risk results. So we've done a study, a sensitivity analysis study, to see the impact of the exposure resolution on risk. And so we've recently just published a paper in BE with the results of that study. For what concerns European vulnerability models, we have built upon the work that GEM, the Global Earthquake Model, has undertaken to calculate capacity curves for a very large number of different building classes across the world. We've used many of those capacity curves for wood buildings, for steel buildings, for unreinforced masonry buildings. But when it comes to reinforced concrete, we've done a more detailed study at the European scale, where we have calculated capacity curves for reinforced concrete buildings as a function of their code level and lateral force coefficient, to tie it up with the study I showed you before on the evolution of seismic design, so we can better connect our vulnerability models to our exposure model. So different buildings of different design codes are simulated, models are developed, capacity curves are calculated, and we use GEM's Vulnerability Modelers Toolkit, which is an open source toolkit, Python toolkit, to calculate the vulnerability curves. And again, everything is available in this GitLab repository. The risk is carried out using OpenQuake, which is open source software. We do an event-based analysis, so we generate a very large number of stochastic events, or a stochastic catalog, if you like, and then for every single event, we simulate the ground motion fields using the ground motion prediction equation, and also bringing in the site amplification model. We combine this with the exposure at the locations of the buildings and the vulnerability models to calculate the risk. We will be releasing a number of pre-computed risk outputs for 44 different countries. I'm just going to show you some examples of those pre-computed risk outputs, but as I mentioned before, all of the input models will be openly released, so people can reproduce their own results and also investigate the risk model using other, perhaps more detailed risk metrics than those which we are able to pre-compute at the European scale. So we'll have maps of average annual loss. We'll show those for different classes of buildings, so residential, industrial, commercial, but also all of the buildings. We can divide that average annual loss by the exposure value to get the average annual loss ratio. We can show maps of the losses for different return periods, and the resolution can vary from a national resolution at the European scale to admin level 1, so that's the first administrative level below national level for each country. We will also produce loss exceedance curves, so they tell us about the losses to the building stock under different return periods. We can compute those at the national level, but also for different parts of the building stock, just for the residential buildings or just for the industrial, and also at different levels of resolution. But we will be releasing pre-computed results at admin level 1. Another product that we plan to release is country profiles. So working together with the Global Earthquake Model, which already releases country profiles for countries all around the world. They will be updating their European country profiles using the results from our European risk model. And so we will be releasing together these country profiles. And everything that I've showed you here will be made available through a WebJS platform, which will have associated web services. And that's available at this website here. One product that we feel is particularly important to communicate seismic risk to a wider audience, not just to our own community, is a simple representation of seismic risk. And we've decided to do this through what we call the Seismic Loss Index map. This is a map that combines average annual loss and average annual loss of life in a single index, so that these two parameters are normalized and combined. You'll hear more in the presentation by Michelle about how we are currently testing these maps with students around Europe. Particularly this color scale is something that, and understanding whether the results can be understood is something that we're doing before we produce our final maps and posters. So the final steps to the release, we are waiting for the final stamp to be put onto the European seismic hazard model so that we can then really carry out our final sanity checks of the European seismic risk model. So whilst we have been testing the various components, the vulnerability exposure separately, we need to really test the whole integrated framework to make sure that the results make sense. As mentioned previously, everything will be publicly released. You'll hear more about the open source licensing that we're putting on the products from Fabrice. There'll be a technical report, which will be very important to help people to understand the components. We plan to officially release the models in October or November. We don't yet have a release date, but please do sign up to the Affair newsletter to find out exactly when that will be. Here, I'll just leave a number of publications as I've shown in my slides. And of course, if there is any questions, please do contact us and we'll be very happy to provide you with more information.